test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers is it, triggers is it, triggers is it, triggers is it. Seeing Mr. Ng's face during period 3. Triggers is it, triggers is it.
Hey guys, let's go over 1.84, solving a linear quadratic system by graphing just essentially a word problem. Go ahead and do this problem with me, and then you'll get to pick one of the questions. That should say 16 or 17. A software developer determines that her company can model their revenue, which is R. I'm going to box that so I remember that. And let's go dark mode. From a given product and hundreds of thousands of dollars given the unit price of the product, X, let's just say X in dollars with the function R is equal to negative 0.1 x squared plus 4x. Create a linear quadratic system and solve it graphically to determine the price which the company will earn $4.2 million. Okay, the first thing we need to do is figure out. The first equation we're given is the revenue model, right? R for revenue. And that is R equals negative 0.1 x squared plus 4x. Okay, the second equation that we're given is we want to have a revenue of 4.2. Okay, so, sorry, let's see. I know it's, so it says hundreds of thousands of dollars. So 100,000 times 42 would give me the 42 million. So what I'm trying to say then is that number is 4.2. Okay, so those are my two equations. Let's go ahead and graph this system. R for revenue, and this is measured in $100,000. And so you might have something like 5, 10, 15, 20, 25, 30, like that, 30, 35, 40. So I'm going by fives. And then over here, I'm going to have the price of this item, which is measured in dollars. We'll also go by fives. 10, 20, 30, 40. Okay, so if I just graph this, let's go ahead and just put it into the graphic calculator. Clear this out. Negative 0.1 x squared plus 4x, and then this one would be 42. All right, let's kind of graph this. Pinch down. There it is. Okay, something you'll notice as you zoom in is that there is no intersection. Okay, so let's go ahead and make a graph just like ours. So in orange, I have 42, which is kind of represented by, let me draw a thicker line, something up here. And then the light blue is a parabola that they did not intersect. And what does this mean? The graph of the functions or of the systems do not intersect. So there's 0 solutions. What does that mean for this company? Their revenue will never reach $42 million. Okay? All right, go ahead and pick one of these, 16 or 17, and we'll do this together. Number 16. Civil engineering. For safety, roads are designed to ensure that rainwater runs off to the sides. Many roads are highest in the center, so that a cross-section of the road is a parabola. Suppose the surface of the road can be modeled by y equals negative 1 over 300 x squared plus 3/4 x, where x is the distance in feet from the center of the road, and y is the height in feet of the road above the shoulder. Okay, so let me go ahead and just draw. Let's see if we can get this in here. This is my parabola. That's what they're trying to. See, it was so bad. Let's see. Does this make sense? What's happening there? That's kind of like my parabola. And so the first question is, how wide is the road? Okay, so they want to know. They want to know this is how wide, this length. So basically what I can do is just find the X-intercepts. Find, and this is going to be super important for your projects, so find the distance between X-intercepts. Okay, so we can just graph this, or you could just mark up the picture. And the nice thing about this, the graphing calculator on an app or tablet like I'm using, is it does all this zooming for you super easy by just pinching the screen going out or in. Before, it was a lot of work to kind of change the window, it's called. Negative 1 over 300, close the parentheses, x squared plus 3/4. If I have not shown you this, there is another way of getting the fraction. I'll do it for this one. Oh, didn't mean to do that. Okay, let's just use, it's there in pink on my screen now. So I have to press alpha y equals. Alpha y equals. And then you just pick ND, numerator, denominator. And then you just type 1 down 300 and then go right. Close your parentheses, x squared plus, show it again, alpha y equals in the top left. Numerator over denominator, and just makes it look nice. And go out by pressing right, and then you can press graph. Okay, here's mine. Now, there's a couple of ways. Of course, it's easy getting it graphically, right? I can just hit there and move my finger. So it says 0. You can also press the word calculate. And if you want a 0, I think you're typing in numbers. So negative 16. Let's say I want to get the other one. And then I want, let's say, it's between negative 14. And then it's actually telling you the word, where it says the word 0, it's actually calculating it for you at negative 15. But obviously we kind of just did that by just tracing it and moving it. So at negative 15 and positive 15. Okay, so this is at negative 15. this is the origin, and this is 15. That means this has a distance of 15 and 15. So 15 plus 15 is 30. The road is 30 feet wide. Another way that you could have solved this problem is, it says y equals, instead of just by graphing it, I can just move that 3/4 to the other side. Remember, this is 0. Because the reason why y is 0 is because this order pair here is negative 15, 0. Does that make sense? So if I set y equals 0, I'm solving for the x. So I'm trying to show you a second method. I'm going to multiply both sides by negative 300 to clear that fraction. On the right side, my negative 300s would cancel, and over here you'll get a positive 900 over 4, and then you can just use the square root method. So square root of 900 is 30 over 2, and when you do that, remember to have a plus or minus, so basically that becomes x is positive and negative 15, which was the numbers I found here and here. So that was the second method. B, if the water level during a flash flood is 6 inches above the shoulder, about how wide is the portion of the road that is not under the water? So if I draw myself a quick graph, this is my road exaggerated, and then I do something like this. We're saying this is at, okay, pay attention, 6 inches. 6 inches, well, 12 inches is 1 foot, yes? So 6 inches is then half of a foot. Because everything has been measured in feet. So I've just basically transferred this. So this is at 0.5. And now they want to know how wide is the distance from here to here. Well, to do that, now I have an equation, 0.5, that's equal to that formula. Negative 1 over 300 x squared plus 3/4. And so the 0.5, I guess you can just kept it a fraction. Yeah, the reason why now I'm noting is it's a fraction. I could just done this 1/2. So if I subtract 1/2, which is just essentially that's 0. And how do you subtract that? Just multiply by 2 over 2. You'll get negative 2/4. So 3 and a negative 2 is positive 1/4. And then you would just go about doing the same thing we did before. Subtract it. Multiply by negative 300. Cancels, 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 cancels. You're left with x squared. This will give you, oh, that was a negative. So cancels, cancels, 300 over 4. And if you just took the square root of that, you can just, let's do it together. 300 over 4. Second, x squared. 300 divided by 4. Press the out key, and you have about 8.67. So plus or minus 8.67. Okay, so that means do some magic here. good. Why did I move it is because this number is negative 8.67 and this one is positive 8.67. So that means from here to the origin is 8.67. Well, that's cool. Didn't know I could do that. And this one's 8.67. So if I add those together, I'm going to get, well, 8.67 times 2, because we rounded up there, 17.34. So the road is 17 point, what did we say? $17.34 feet wide. And this is when the water has risen, if that makes sense. It was this distance here. Okay, let's go ahead and try question number 17. Small business owner determines that the profit in P dollars from sales of a specific item can be modeled by P equals 2x squared plus 30x, where x is the selling price of the item in dollars. Create a linear equation to determine the price for which the business will earn $50,000. All right, so my two equations are P equals 2x squared plus 30x and P equals 50,000. Okay, so I have this equation here. Now notice they're both set equal to P. So if I set them equal to each other, because they're now set equal to P, does that make sense? Okay, let me show you one other way. P is equal to 50,000 and P is equal to 2x squared plus 30x, so you can kind of basically delete that. Now they're equal to each other and you just subtract. Okay, so let's put that into our graphing calculator. 2x squared plus 30x minus 50,000. Keep pinching to find so I have 50.79 and negative 165.79. Let's write that down as our solutions. X is approximately 150.79 and also 165.79. And then, what does this, that one was a negative. Okay, what does the solution set of the system mean in the context of this situation? Okay, so let's just say let's think about this. I'm recording this video and it's almost Black Friday, Cyber Monday. I'm going to do lots of shopping, you're going to do lots of shopping. Let's just say we own a small business called MrMathBig.net. And let's just say profit means what? Positive, and negative means I lose money. So would it make sense to give away $165.79, like I'm giving away free, I don't know, expensive flashlights, and I get a profit of 50,000? Does that make sense? So although it's a solution, it's not a viable solution. So I'm just going to write that. Solution, but not viable. And I'm just saying it's not a real, like, it wouldn't make sense. Like, why would I give away money why would I give away money to make 50,000? So let me make this visual, and maybe this might make sense, right? So we said this is 150.79, and this one over here was like negative 165.79. So if you think about it, this portion over here, this is the only portion that you're really thinking about, right? All this other one with the pink dot that I have, this area, although mathematically, yes, it's part of the parabola, I don't want to give away money. I don't like giving away money. So let's write a summary here. Selling price can't be negative. Selling price can't be negative. So 150.79 comma 50,000 is the only viable solution in this context. I don't know why I just capitalized I there. What else does this mean? So after selling the product, these expensive math flashlights, because I have a flashlight in front of me, after selling the product for about $150.79 per item, then the company can profit $50,000. So of course, if I charge more than $150.79, I'm going to get more than $50,000. But the point is, that's the kind of like the cost. You know, like if I'm trying to say, hey, I got to pay back my sister for borrowing $50,000, I better charge $150.79 per flashlight. And that was 1.84. We'll see you guys later. Bye.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.